No, I cannot. All right, guys, I just got to turn on my noise. All right. All right, guys, are you ready? We're going to talk about circles. John, just so you know, I did get your pictures, and I will get those grades in for you by the end of today. All right, we're going to talk about circles because that's what we're on. Who's on circles? Anybody? No, 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 no. All right, well, we're going to talk about them anyway.
Is that week 8?
Week 7. Since you are here, oh, good, John, excellent. Remember, since you're here, you can go to the webinar discussion page. If you've attended, you're good to go. All right, so circles. A circle features what? And the circumference is? Say again. You said the sides, right? So it's the outside part. The circumference is the outside part. The distance around, or its perimeter. All right. What else does it have?
Diameter.
Diameter. What's the difference between diameter and radius?
The radius is half the diameter.
Good. Radius is half the diameter. Yes, John. Excellent. Okay, so the distance across the circle is the diameter, and this is passing through the center. So you have to be sure that it goes through the center. The radius, does it have to go through the center? No. Just as long as it starts at the center point and goes to one of the circumference. All right, what else? This is called a chord. All right, and a chord is when you go from circumference to the circumference. Okay, just 2 points. This over here is a minor segment. This is a major segment. I'm not sure if the videos go over that or not. This is an arc. John, if you finished it, do they go over the minor and major segments? Okay. Didn't listen. All right, so an arc is just part of the circumference. Something that is tangent, it touches the circumference, or it touches something only at one point. So tangere means to touch. I don't know if that's how you say it or not. All right, properties of a circle. When angles, triangles, or quadrilaterals are constructed in a circle, the angles have certain properties. So we're going to look at 4 such properties, and then we've got some questions. All right, so an angle on a chord. So this part down here is our chord, and when I take these lines and I, not join them, well, I'm going to say join, but I draw them to any point on the circumference, the angle is always going to be the same. It's always going to be 47 degrees. In this particular case, they're just saying it's 47. Does that make sense? Okay, remember that. So an angle that sits on a chord does not change as the apex moves around the circumference, right, Jordan?
Yes.
Important part about being here and saying attended is that you participate. All right, so it's got to stay right here, and it's got to be above or on the major segment. Okay, this part down here is 133. What does 133 and 47 add up to?
180.
180. Good. So we say angles are subtended by a chord in the same segment, or they're equal. Okay, so subtended means these. Alternately, angles subtended by an arc in the same segment are equal. So from now on, we'll only consider the chord and not the arc. All right, so we're just going to look at the chord. Okay, so look at the circle. You guys should be able to do this fairly easily. Find angles A and B.
Can't see the last one.
Can you see him? Okay. So what do you think angles A, what do you think angle B is?
A is 152.
And angle B,
136.
okay. So we're going to imagine a chord. Make sense? All right, so if this angle over here is 28, what do you think this angle over here is? Angle B. (28°). Remember, because we have this chord that's here, any angle that's subtended like that, it's going to be the same. Okay. So what if we have a chord at the other end? If this angle is 44, what's angle A? 44. Very good. Yes, John, you are right. All right, so very often I wouldn't try to confuse you. But they draw their own chords. You guys just have to figure out where they go, okay? Okay, so you have to see the angle on the same chord all by your lonesome. So, angles at the center. If we have a center angle that's 88, okay, that's the same chord, but what do you notice about the angle at the circumference? What do you guys notice about this angle compared to this angle? Say again? It's smaller, right? And what it is actually half the center angle. Okay? So we're looking at the same chord. The angle in the center is twice as big as the angle that goes to the circumference. Okay? So if two angles stand on the same chord, then the angle at the center is twice the angle at the circumference. So it's still true when we move this around. Make sense? Okay. All right. As long as the segment, it stays on the same segment. If it goes to the opposite side, it's 136. All right. Okay. Of course, the reflex angle at the center is twice the angle at the circumference. So if this angle is 36, this angle up here is twice that, so it's 272. Okay? All right. More angles. This is a special case. So when the angle stands on the diameter, so again, this is the diameter, right? It goes through the middle. What is the size of angle A? So close.
40.
No, 80, 85 is closer than 40. What is it?
90.
90. All right, so the diameter is a straight line, so it's 180, right? And so that angle is 90. Does that make sense? All right. So the angle in the semicircle is a right angle. So cyclic quadrilateral is a quadrilateral whose vertices lie on the circumference. Okay, opposite angles add up to 180. So these two angles add up to 180, and then these two angles are going to add up to 180. And how many degrees are in a quadrilateral? 360. In a really? All right, guys, let's not do this. Help me. Thank you. I don't know how you did that. You'll have to show me later. Okay, these are supplementary, right? Anything that adds up to 180 is supplementary. Side note, anything that adds up to 90, what kind of angles are they?
Right angle.
I mean,
I just had it in my head. What's it called when an angle adds up to 90? Complementary. Okay, so again, it doesn't, again, you see these, this is a quadrilateral. It's got 4 corners, right? So it's got to add up to 180. Opposite angles add up to 180. Okay, so here's a question. This angle right here is 63. What are angles alpha and beta? A little bit of math. What's angle alpha? If this one is 63, what's angle alpha?
twice.
No, what did we just say about these quadrilaterals?
It's 130 points.
It adds up to 180. So 180 minus 63, 127. Okay, so if this is 180, 127, what do you think these are? Look at this angle. Remember, this is going through the center. It's going through the diameter. This is 90, so what is this one? This whole thing is 90, but this is half, so it's 63, 90, it's whatever's. This is a triangle. How many degrees are there in a triangle? 180. So this is 63, this is 90, right? So this is going to be whatever, 180 minus 90 minus 63. 30 something? Quick. Math whizzes. Okay, I'll go with that. Okay, let's look at this. So this angle up here is 49, yeah? What's this angle right here? 98. 49 times 2, right? The angle in the center. Remember, this is our chord. We're imagining our chord right here. This angle is twice the angle that's at the circumference. All right, so what's this angle? Angle N. That one's hard. I guess I didn't bring my notes, so I can't remember. Okay, this is, oh no, it's not that hard. What is it? Again, remember this is a chord right here. This angle is 49, so what's this angle? 49. Does that make sense? Because they're off of the same chord. Okay. So this angle is 49. What is J and K? Which one's 98? K. This one is also 98 because they are opposite each other, right? And they're in a quadrilateral. So just look at the shapes. It's kind of fun. Okay, this one's 46. What we want to know is what is S? $92. Look at the shapes, guys. This is an important thing. Look at your shapes. Right? This one's 46. This is the center. So what is this line right here? What are those lines? in relation to the circle, what are these lines? This is the center, so this is a radius, right? Center out to the circumference, that's a radius. So this is a radius. So these two lines are the same, right? Let's think about a triangle. This is a triangle that has two sides that are the same. So this angle is 46. What's this angle down here? 46. So what's this angle up here? 180 minus 92. 88. Okay, so if this is 88, yeah, what's this? Say again? 44. Okay? Kind of like a big puzzle, right? We love puzzles. All right, so this is something that's kind of fun too. This angle over here is 104. What's this angle over here? It's not opposite, right? This one is 104. So what's this one? This is a line. What do angles on a line add up to? 180. So if this side is 104, this side is 76. Yeah, good. See, it's just fun, right? Okay, now we're going to talk a little bit about tangents. What are tangents again? Anybody? Nope. Tangents are lines that just touch the circle or just touch something else. A tangent line is, they only touch in one spot. Yes. Okay, so a tangent is perpendicular to the radius. So what's important here is that the radius, if you were to draw a line from the center to the circumference, the radius and the tangent line are going to have an angle of 90 degrees. Okay. So, two tangents from a point outside the circle, 90 and 90, all right? Make sense? Are we good? Okay. Tangents are equal, so PA is equal to PB, those lines are the same, and PO bisects this APB. Trying to think how to draw this. So, angle APO is equal to angle BPO. Make sense? Because it's a bisector. And the outside angles are 90 degrees. This is a radius. So two triangles are congruent. What does congruent mean? Equal. They're the same, right? All right. So if this angle is 39, again, think of this as a chord, right? This angle out here would be 39. This angle over here would be 57. So the angle between a tangent and a chord is equal to any angle in the alternate segment. So there's the angle between the tangent and the chord, and there's the alternate segment. All right. I think that's it, guys. It won't go anymore. I forgot to put my question slide. So that's fun. John, you've already done this. Was it very hard? Well, that's not bad. That's pretty good. Okay, so guys, out of all of the assignments, John only had trouble with like 2 or 3 problems. And I think there are, how many? There are 3 assignments. So week 7 is pretty easy. And I think there's just a week 8. There is no week 9 because you guys will be doing what? Park testing. You guys are so lucky.
When does this quarter end?
Pardon me?
This quarter.
I think the 2nd week of March. So we're almost done already. I know. All right. So do you guys have any questions about circles and angles? No and no. John, any questions? Circle and angles? When you become an architect. When you design a satellite dish. All right, guys. That's it.